Hello, viewers. In today's session, we are going to discuss some important problems related to Dirac delta function. Right. So, in this session, I will solve some integrals involving the famous Dirac delta function, and we'll see how easily we can solve these type of problems using the properties of Dirac delta function, right? So let us consider the problems one by one. So let us first consider this integral, and here we have to evaluate the integral from minus infinity to infinity, and here we have e raised to minus x square over 2, and this is a Gaussian function, and delta prime of x minus 2 dx. Right, so here we can see that we have the first derivative of Dirac delta function. So in order to evaluate these kind of integrals where the derivatives of Dirac delta function are involved, we have to make use of this important property which says that the integral minus infinity to infinity, and if we have here a function, say f of x, and here we have the nth derivative of Dirac delta function, then the value of this integral is equal to minus 1 raised to n, and here we have the nth derivative of this function f of x evaluated at this point, that is x is equal to a, right? So this is an important property of Dirac delta function involving the derivatives of delta function. So here we have minus infinity to infinity, and we have a function f of x associated with the delta function, and here we have the nth derivative of delta function, right? So the value of this integral is equal to minus 1 raised to n, and here the nth derivative of this function f of x evaluated at this point, that is x is equal to a. So we'll see how we can apply this property to this integral. So now let us compare this integral with this one. So we can see that our function f of x is given by e raised to minus x square over 2. And here we have delta prime. It means we have the first derivative of delta function, right? So here the value of n is equal to 1 because the first derivative of delta function is involved, and here we have x minus 2, here we have x minus a, so the value of a is equal to 2, right? So now the value of this integral can now be equal to this expression. So we have minus 1 raised to n, n is 1, and here we have f, and n is equal to 1, so we have the first derivative of this function f of x evaluated at this point, that is a is equal to 2. So minus 1 raised to 1 is minus, and here we have f prime of 2, because f1 2 can be written as f prime of 2. So let us differentiate f of x to get the derivative of f of x. So f prime of x is equal to d by dx of e raised to minus x square over 2, and the derivative of the exponential function is the exponential function itself, and by chain rule the derivative of minus x square over 2. So we have e raised to minus x square over 2, and here we have minus 2x over 2 because the derivative of x square is 2x, and 2 and 2 get cancelled, so we have minus x e raised to minus x square over 2, right? So now f prime of 2 can be obtained by replacing x by 2, right? So here we have minus 2 for x is equal to 2, and e raised to minus 2 square over 2. So this is minus minus plus, and we have 2 times e raised to minus 4 over 2, that is 2 times e raised to minus 2, right? So this is 2 divided by e square. So the value of this integral is equal to 2 divided by e square. So now consider this problem here. The integral is 0 to infinity, and we have this polynomial, that is 2x cube plus 3x square minus 5x plus 1, and delta double prime of x minus 1. So let us compare this integral with this one, and here it is important to note that here the limits of integration are from 0 to infinity, but here we are taking the limits from minus infinity to infinity. So here the point of consideration is 1, that is a is equal to 1, and 1 lies within this domain, that is 0 to infinity, right? Okay, so comparing this integral with this one, we have f of x is equal to 2x cube plus 3x square minus 5x plus 1. And here we have the second derivative of delta function. Here we have the double prime, so the value of n is 2, and the value of a is equal to 1, and we can easily see that this point a is equal to 1, it belongs to this domain 0 to infinity, right? So the value of this integral is equal to this expression. So we have minus 1 raised to 2, and then f, and here the second order derivative, that is n is equal to 2 and a is equal to 1. So minus 1 square is positive. So we have simply the second derivative of f at the point a is equal to 1. So let us differentiate this function f of x twice, and we have f prime of x is equal to the derivative of x cube is 3x square, so we have 6x square, then we have here 6x, and then we have minus 5, right? And then the second order derivative is given by 12x, and here we have simply 6. Now taking x is equal to 1, the value of f double prime of 1 is given by 12 times 1 plus 6, taking x is equal to 1 over here. So we have 12 plus 6, that is equal to 18. So the value of this integral is given by or equal to 18. Now consider this problem, right? And here we have to evaluate this integral from minus 2 pi to 2 pi, and we have sine 2x and delta triple prime. Here the third derivative of delta function is involved, right? So we can also write this integral as minus 2 pi to 2 pi. Then we have sine 2x, and here delta triple prime, and then we have x minus 0, right? So now if we compare this integral with this one, then f of x is given by sine 2x, and the value of a is equal to 0, and here the value of n, that is the order of the derivative, is 3, because the third derivative is involved, right? And moreover, here the limits of integration are from minus 2 pi to 2 pi, but here we have minus infinity to infinity, and again the same reason follows, because this point, that is a is equal to 0, it belongs to this interval, right? So because we know that the delta function is 0 except at this point, that is a is equal to 0. So this point a is equal to 0 belongs to this interval minus 2 pi to 2 pi, right? So now the value of this integral I is now given by this expression. So we have minus 1 raised to 3. Then we have the third derivative at this point, that is a is equal to 0, right? So minus 1 raised to 3 is minus 1. So we have minus f triple prime at this point, a is equal to 0. So now let us differentiate this function. So we have f prime of x is equal to d by dx of sine 2x. The derivative of sine 2x is 2 cos 2x, and then the second derivative, and we have here 2, and the derivative of cosine 2x, so we have 2 times minus 2 sine 2x, right? So this is minus 4 sine 2x. Now the third derivative is equal to minus 4, and then we have the derivative of sine 2x. So we have minus 4. The derivative of sine 2x is equal to 2 cos 2x. So this is minus 8 times cosine 2x, right? So now the value of f triple prime of x, that is when x is equal to 0, can be obtained by taking x is equal to 0 in this expression. So we have minus 8 cos of 2 times 0. So this is minus minus plus, and we have 8 times cosine 0, and cosine 0 is equal to 1. So we have 8 times 1, that is equal to 8. So the value of this integral is equal to 8.